Okay, so now we want to use it for an application type problem. Here we have the length of a shark modeled by that function up there. L equals 330, it's up there. It tells you T is the shark's age in years and L is the length. Now we know if we want to relate this to a graph so we can graph it, we know that usually after the x or after the equal sign is our y. And since we're dealing with exponential functions here, that t is going to become our x. And we need to keep that straight because when we graph it, this one's kind of complicated. We're just going to use our graphing calculator. We want to make sure we know that now x is going to represent the age in years and y is going to represent the length. Okay, so if we look over here on our calculator, graphed our function, we typed it into our y equals menu. Be careful of those parentheses. If it's together, like your exponent there is negative 0.178x, that's got to stay together, so that needs parentheses. So we type that in. Then this is a bigger function, so we want to make sure our window is bigger so we can see it. Something you can kind of do is just kind of estimate your function. If you have numbers in the hundreds, okay, then your window is going to want to show that. A shark can be pretty old. Think of how old a human can be. A human can be 0 to 100 years old. A shark, same deal, okay? And then the length needs to reflect that. That length is measured in centimeters, so you're going to have pretty high values. So go ahead and make your window match mine. Remember, something else you can do is you can just start with that standard window and adjust it. Okay, so once our window matches, we graph it, and you should end up with a curve like that. Okay, that's fine because we just want to graph it. And then that second part says we want to estimate the length of a tiger shark that is 3 years old. Remember that we decided that L is my y now, and y represents length, and x represents the age. So we want to say what is y, what is the length, when x is 3. So I can just go to my calculate menu, I hit second, trace, and we can go to value, number 1. When I go to value and hit enter, okay, that allows me to type in anything for x and it'll tell me what y is. So I want to say, well, when x, my age, is 3, what's the length? And it tells me the length is 175 centimeters. And you're done. That's it. Okay. So we talked in class quite a bit about compound interest. Now with this Euler number, this allows me to do a different type of interest formula, continuously compounded interest. When it doesn't matter quarterly, monthly, whenever it's compounded, they just do it continuously. You would see this in some higher investment rate type deals here. Okay, so when interest is compounded continuously, this is the equation you use. It's still the same variables. P represents your initial deposit, R represents your rate of interest, and T represents your time in years. So for this problem here, if we deposit $4,000 in an account, sounds like my principal amount there, so that's going to be my P. E is a number, so E stays there. That pays 6% annual interest. Okay, that's a percentage. I definitely want that as a decimal. So 6%, I'm going to remember to move that decimal point 2 spaces to the left. That's going to be 0.06. What is the balance after 1 year? So your T is just going to be 1. Okay, you're going to go ahead and put that in your calculator. Please do that now. Okay, so after you do your order of operations, make sure you're careful of parentheses here. You should end up with A balance after 1 year, $4,247.35. Remember, you're dealing with money here, so always round to the nearest hundredth. Please remember for this video, because that's it for 7-3. If you need any help, go back, rewind, and get ready for some practice tomorrow.